Hello, right, this is lesson 7 and it was all to do with expanding brackets and factorising, single and double brackets. So let's crack on with just remind ourselves about expanding brackets. If I can get... So what we do with algebra is we multiply everything inside by the thing that's outside. So we've got 2x times x and then 2x times 4 with a plus sign in the middle. So 2x times x is 2 and x times x is x squared. And 2x times 4 will be 2 times 4 is 8. And don't forget the x on the end. So another one was 4x minus 3. So you've got to take notice of the minus sign in the front of it. So 5 times 4x is 5 fours are 20, x minus 5 times 3 is 15. So you get minus 15. So that was just expanding brackets. Yeah. So now we're going to do it the other way around, where we're going to put something back in the brackets, and this is called factorising. Factorising. Okay, so if we have, say, 4p plus 8q, what we need to do is we need to find the highest common factor of each of the term within what we're looking at, the expression. And we can't pick a letter out of them because we've got p's in the left and q's in the right, so they won't go. But we can have a 4. We can have a 4 because 4 goes into that once and 4 goes into the 8 twice. So 4p divided by 4 is just p, and 8q divided by 4 is 2. 8 divided by 4 is 2q. And we can have another one, 15s minus 6t. So we need to find a number that goes into both 15 and 6, which is 3. That's the highest number. So we put the minus sign down there. So 3 5s are 15, s, and 2 3s are 6, t. There's some more. Now, that's single brackets is quite fair enough. What about when we've got quadratic? Quadratic, double brackets. Double brackets. Now, x plus 2 and x plus 3. Now, we're going to employ something called FOIL. F-O-I-L. And this helps us remind what to do in what order. And the letters of FOIL stand for the location of the bits in between in the brackets. So this means the first, this means the outside, this means the inside, and this means the last. And this is where the things are in the brackets. So we multiply everything in turn. So the first is the x and the x because they're the first things in the brackets. So that becomes x squared. The outside is x times plus 3, which is 3x. The inside is plus 2 times x, which is 2x. And the last is the 2 times the 3, which is 6. Don't add them. Yeah, they've got to multiply. Now, you always end up with 4 things because you've done 4 operations. And you need to simplify this to get it into a 3-term expression. So we can always add the middle bits together. So 3x and 2x make 5x. We've got 6 at that end and x squared at that end. Okay, so that's what we do. So how can it get more complicated? I don't know. Let's do another one. Yeah. So let's try x plus 4 and x plus 5. And it does no harm. Just write FOIL in the corner so you know what you're doing. So the first, x times x is x squared. The outside, 5 times x is 5x. The inside, 4 times x is 4x. And the last, 4 times 5 is 20. All pluses, yeah? tidy up the two middle ones, so we get 9x plus 20 plus x squared. X plus 10 and x plus 8. So you can always pause and have a go before I do this. So x times x is x squared. First, outside, x times 8 is 8x. Inside, 10x. Last, 80. 18x in the middle, plus 80, plus x squared. We will be going back the other way in a later lesson. Now let's put some minus numbers in there for us. Let's see what happens with minus numbers. So let's have x minus 4 and x plus 3. So we've got a minus in one of the brackets. So FOIL, don't forget FOIL. X times x is x squared. X times 3 is plus 3x. Minus 4 times x is minus 4x. And minus 4 times 3 is minus 12. Tidy up the middle. We've got plus 3 and minus 4, so we end up with a minus 1x. So we don't need to write the 1, minus 12, and x squared. Let's put a minus in both. X minus 4 and x minus 2. So x times x is x squared. Outside, x times minus 2 is minus 2x. Inside, minus 4 times x is minus 4x. And minus 4 times minus 2 becomes a plus 8. So minus 2 and minus 4 make minus 6 plus 8x squared. Let's do another one, shall we? X minus 10. And you can never do enough of these, yeah? Minus 2. Once you get the hang of going backwards and forwards, you can double check your answers, but we'll do that later on. So again, don't forget it's FOIL. So x squared minus 2x minus 10x plus 20 minus 12x plus 20 and x squared. They're very easy once you get the hang of what's going on, yeah? And so you can get, just to make life a little bit more awkward, you can get a number before the x, like that. So this time with a FOIL, yeah, we've got 2x times x this time, so that becomes 2x squared. And the outside is 2x times 5, which is 10x. The inside is 3x. And the last bit is 3 5s are 15. So merge the two together to give 13x plus 15, plus 2x squared. So you can get numbers in there as well, so be careful with that. Now sometimes they will give it to you like this with a square. Now don't worry, it's still a FOIL question, but there's something to do before you actually get to the FOIL. Is but this is squared, it means x plus 5 times itself. So you may as well just write it like this, x plus 5 times x plus 5. And we're back to the double brackets that we can FOIL. X times x is x squared. X times 5 is 5x. And we got another 5x for the inside. And 5 5s are 25. So that gives us 10x plus 25 plus x squared. Yeah. Now, so that's expanding double and single brackets. Then this I think is a little more difficult when we factorize. And what we're doing is let's have a look at some examples. factorise is when we have, oh, I did factorise earlier on, didn't I? Yeah, let me go back. Did I do factorise? Just factorising. Oh yeah, done that bit. Okay, ignore that, ignore that. So let's do expand and simplify. Simplify. Now you can get something really crazy. You can get brackets all over the place, yeah? So all we need to do is take it one step at a time and see if we can simplify when we get to the end. So we've got three distinct parts, so we can do one part at a time. So x times 2x is 2x squared. X times 1 is just x. Then we do this one, so it's a plus. Y times y is y squared, and y times minus 4 is minus 4y, and 3x times y is 3xy, 3x times 2 is 6x. Can we collect like terms anywhere along there? Yes, we've got some x's there and some x's there. So I'll rewrite this. There's nothing else the same. So this becomes 7x now, plus y squared minus 4y plus 3xy. Now the next thing we looked at was dots, which is the difference of two squares. So what we've got to know square roots to do this. So the square root of 49 is 7, because 7 sevens are 49. The square root of 81 is 9. The square root of x squared is equal to x, because x times x is x squared. So the square root of x squared is x. This is just like saying the square root of 7 squared. Yeah, it's the same thing, but we've got letters. And that's the same as the square root of 9 squared. It's just a number inside. And we do get some odd ones, whereas the 7 and the 9 come out as whole numbers. If we do the square root of 15, we know that the square root of 16 is 4, and the square root of 9 is 3. So it's somewhere in between there. Now for this exercise, we don't have to try and work out whether it's 3.1, 3.2 or something. We just simply write what it is. The square root of 15 is the square root of 15, end, job done. Okay, so you can get something like this, and it will be x squared, it's always a minus, yeah? And we've got to do the difference of two squares, so we put these in double brackets. Now the square root of x squared, as we said, is x. So you put an x in both brackets, and you put a plus and a minus. And the square root of 49 is 7. So you do the square root of the number and the square root of the x squared, and you have a plus and a minus. If you get the plus and the minus the other way around, it won't make any difference. But this is why. Now if I FOIL out this, I go x times x is x squared, x times minus 7 is minus 7x, 7 times x is 7x, and minus 7 times plus 7 is minus 49. Looks similar to that, but look, the middle bits are minus 7x and plus 7x, which will cancel themselves out, so you're just left with that. So it's going from this, using the difference of two squares to do double brackets, and you could, if you want to, try and FOIL them back out to see whether you get your original question. Let's have a look. Yeah, I will do that. Must have done things all in the a different order. I will do some more factorising. So we're going to go 6x plus 9xy. So we put the bracket down there, and what we've got to do is try and pull out the highest common factor of each of the parts of the terms. So of the numbers, the highest common factor there is 3. Leave a bit of space in case we need letters. Oh, there's an x in both terms, so we can take an x outside. So what we do is 6x divided by 3x is simply 2. 3x times 2 is 6x. Put the plus sign in there. 3 times 3 is 9. We don't need an x because we've got one there, but we do need a y. So 3x times 3y is 9xy. 20y minus 12xy. So big brackets, minus sign in the middle. What's the highest common factor of 20 and 12? It's 4, isn't it? Yeah. And there's a y in each of the terms, so we'll take a y outside as well. So 4's into 20 go 5. Don't need a y because we've got one there. And 3 4's are 12. We need an x. So 20a squared plus 28ab. Right, so big brackets, big brackets. Highest thing that goes into 20 and 28 is 4. And we've got a's in both of them. We've got 2 a's in there and 1 a in there. So we take 1 out from each. And we can't take a b out. So what is this? So 4 times 5 is 20. A times a is a squared. 4 times 7 is 28. We've already got an a there, so we just put the b. 12pr plus 8pq minus 20p. Whoa, we've got 3 bits here. So we need a big, long bracket. So there's a plus in that bit and a minus in that bit. So we need a common factor of all of these things, which is what goes into all of that. Let's say probably a 4, isn't it? Yeah, a 4. We've got a P in everything, so we put a P there. We've got an R and a Q, and yeah, so we can't do that. So 3 4's are 12. We don't need a P, we've got 1, so we just need an R. That's a plus, not a T. 4 2's are 8. We don't need a P, but we need a Q. And 5 4's are 20. We don't need a P, so that's just the 5. Right, so let's, these are all right, these, aren't they? Let's put a minus 21 RST plus 33 R squared S minus 6 RS squared T. Oh, right. So we have a minus and a plus. Now, what can we take out of there? Oh, we have to have a minus there because it's a minus. So what goes into all these? Well, 6's don't. So it must be 3's, yeah. 3's into 6, 3's into 33, 3's into that, yeah. So we can take a 3 outside. Now we've got an R in every term, at least. So we can take an R outside. We've got an S in every term, at least. So we can take an S. But we don't have a T in the middle, so we've got to leave the T's where they are. So 3 times 7 is 21. We don't need an R, we don't need an S, but we need a T. Now 3 times 11, we do need an R because R times R will be R squared. We don't need an S, so that's it. That's all we can do with that one. And 3 times 2 is 6. We don't need an R because we've got 1. We do need an S because S times S is S squared. And we need a T, 2ST. That was it. Yeah, that was it for that lesson. So there'll be another part of this where we went through a little quiz. So that's all for that one.